Hello. So in today's class, we'll do the same thing that we did yesterday, linear regression. But I will introduce you to the Sklearn library. So the Sklearn library is a library used for machine learning functions. It provides machine learning functions, allows you to use machine learning functions. Do you understand that? So, such as you want to perform linear regressions, you want to use some performance metrics like mean square error, uh, accuracy. You want to compute accuracy, any form of machine learning functions. It allows you to use machine learning functions. That is what the sklearn library does. So,
it allows us to use
machine learning functions.
Okay.
You understand that sklearn, it allows you to use machine learning. It's for machine learning.
Okay.
Machine learning functions. So if you want, for example, this particular linear regressions, there's a way we can solve it instead of using the formulas that we provided. There is a function for that in sklearn that can solve linear regression. Do you understand that?
Okay.
Instead of using that particular formula that was used yesterday, so you can actually use this sklearn to solve that. So if you want to install a sklearn library, so if you want to install sklearn library, you use this function, you use this code, command line code, pipe install. So the name of the library is scikit-learn. Scikit-learn. So once you say pipe install scikit-learn, you are trying to install sklearn. But it's already installed here. sklearn is already installed here. So, but if you need to install it, so you use pipe install scikit-learn.
Okay.
So you can see that you say your requirement already satisfied because you already have sklearn in this Python machine. So let's continue. Okay, so let's mount our drive like we always did. So I'm going to copy I'm trying to copy the authentication key to mount the drive. So we can prepare our X and Y like we did yesterday. Prepare X and Y's. Then once you have X and Y, we can use this sklearn code. So let's go to sklearn. If you want to use sklearn, if you want to use any function in sklearn, you can type it on Google like this. Like I want to use sklearn. I want to perform linear regression in sklearn. So you don't need to cram anything. So just type it in Google that you want to perform linear regression using sklearn. So you have this linear regression code.
Okay.
So this is the linear regression function in sklearn. You can see that if you want to use it, we have linear regression, which is under linear model under sklearn library. Do you understand that? So this is a linear regression function. It's under linear model. under the Sklearn library. So, and this is how it is being used. This is an example. This is an example. You can see this is an example. Import Numpy as MP in from sklearn.linear model, import linear regressions. This is an example. So if you want to use that,
Okay.
let's prepare our X and Y first. So if we prepare our X and Y like we did yesterday, we extracted 2008 to 2015. 2008 to 2015. I'll just copy the code for the economic data. So this is the code for the economic data. So this X, okay, this X for economic data. Within that period that is needed. So this is our GDP. We did this one yesterday. I don't need to explain that.
Yes.
Okay, so I'll also copy this one also for Y, house pricing for Y. So this house pricing for Y. Then I can then use this function. So this is the function from sklearn.model import linear regression. I don't need that linear regression formula because this particular code is going to do everything. So this is how to use the code. This is the regression model. Regression equal to linear regression dot fit x comma y. So our x comma y in our case is this x and y, x and comma y. So once you run this, okay, I think they are not of the same shape. Wait, let's look at the x shape, x dot shape. So this one is in 96, y dot shape. Okay, let's try to reshape it. X equal to mp dot reshape. So x comma, mp dot reshape. We've done that before. 1 comma length of x. So the reason for reshaping it is that if we don't reshape it, this particular function won't work. It has to be in form of 91 comma 1. That's 91 observation and 1 colon. 96 comma 1. 96 observation and 1 colon. Yes. So with this now, we can use the function. So this is the function as it has been used here. I'm going to explain the code again now. Are you following?
Yes.
Okay, so in this particular line, you can see that I've extracted my x and y. I prepare x and y. You understand that because we did this yesterday. I prepare x and y here. Do you get
Yes.
that? You should understand this. I prepare x and y here. So this x and y is what is going to be used. Do you understand that? You know that our linear regression model will accept x and y, and it's going to fit a model. The model, you can estimate the coefficient of the model. These are the coefficients. Coefficient means the slope, and intercept means the intercept that was calculated. It's just the same thing that we've done, just like this particular function is going to calculate everything. We don't need that particular formula again. This one is much more simpler because you don't need this linear regression formula that was used yesterday. So here we prepared x and y by extracting 2008 to 2015. So this is the same thing that was done here. We prepare house pricing data by extracting 2008 data from 2008 to 2015. Do you get that?
Hmm.
So after extracting this period, we have our x in form of arrays, y in form of arrays. So we need to reshape it into the shape of x and y. If I run this code normally like this, then I'll have a shape x dot shape. So it's just the shape is not well formatted for this particular function to be used. Something like this 96 comma. So it has to be 96 comma 1. So that's you have to reshape it into len 96 comma 1. So this is the new shape. Then
Okay.
x, which is 96 comma 1. So it means that 96 comma 1 will be the new shape. So we have x equal to np dot reshape s comma x, and y is equal to np dot reshape y comma y x. So do you get that? So after reshaping it, then you can then use this function. Regression equal to linear regression dot fit s comma y. So once you just say reg dot intercept. So you have this intercept. So we have the same intercept like the one that we used yesterday. Reg dot coefficient will give us the slope. So the slope, we look at this one that was done yesterday, see that we should have the same thing, the intercept and the slope. Okay, if you print the intercept and the slope, we didn't print that yesterday, but if we print it, we should have the same thing. You understand? Or we can try to calculate it again with this formula. This is the formula for the slope. So if you calculate it like this, you see that it's the same thing. Do you understand that? The only thing is that you don't need this particular formula again. This function is going to calculate everything. Do you understand that?
Okay.
It's
Okay.
already in this function. That is what the sklearn provides. Most times you have machine learning algorithms that are very, very complex than these linear regression models. So that is why this function sklearn libraries is being used for such cases. This one is simpler. We can easily write the code from scratch. But there are some that, like our logistical regressions, k-nearest models, decision trees, and algorithms, you might not be able to write the code from scratch. That is why we use sklearn functions. The code has already been written in this linear regression functions, and it can be accessed from linear regression model under the sklearn. Do you get that?
Hmm.
Do you get that? So another, if you look at this also, this is the slope. If you try to calculate the slope also, I mean the intercept from the slope. If this is the slope, this is the slope. M is equal to the slope. So if you look at the intercept, you have this intercept value also. Intercept value, reg.intercept. So in summary, sklearn library is linear regression from sklearn is the same thing. Just that you don't need all these formulas. It's much more simpler. Just reg equals linear regression into brackets dot fit x comma y. This that you are fitting linear regression model using your x and y values.
Okay.
Is that clear?
Okay.
So another thing is that you can then predict. You can y pred can then be estimated like reg dot predict. So you can now predict x. Do you understand that you can predict x? So in our case, because we want to use our we want to do it from scratch, you have to use this formula mx plus b. But this reg.predict is the same thing that like using the formula. So it's going to predict it using that particular formula mx plus b, and it's going to estimate your y pred. Do you get that?
Okay. Okay.
So then you can then plot your graph like this, the same graph that was plotted. So this is the same graph that was plotted yesterday. I'm going to plot it now. Look at this. So you see that the same thing. See that the predictions are the same.
Yes.
Do you understand that?
Yes.
So this sklearn library provides lots of functions, a lot of functions. So if you want to use it, just you can Google it, then look at all these documentations, the parameters that it takes, the attributes. The attribute is the output, like dot coefficient is going to return the coefficient means slopes. Dot intercept is going to return the intercept. Do you understand that? So also in sklearn library, for example, if you want to use the mean square error, mean square that was used yesterday, so you can also just try to look at it like this. I want to use mean square error, sklearn mean square error, sklearn mean square error. So you have it. So this one is under sklearn.metrics. So it's under sklearn.metrics, and it's mean square error is under sklearn.metrics. So if I want to use it, I'll just say from sklearn dot metrics import mean square error. So all these errors are under this sklearn dot metrics error evaluations. So then I can then evaluate my code. So it's going to take these two values, the true values and the predictions, for you to evaluate your predictions. So in our case, we have y pred and y. So y is the actual pricing and y pred is the predicted pricing. So do you get that? Hello?
Yeah.
Hello,
we get.
hello, do you understand that? Anjina?
Yes.
So that is that about
mean-
sklearn. Or do you have any question? Do you have any question?
Yeah, I want to ask something.
Okay.
I mean the value of this mean square error. It can help us to interpret the figure, right?
In most cases, mean square error, the lower your mean square error, the better your model. The more efficient your model is. It's an error measurement. So the lower your mean square error, like you have two models and you have one to be this particular mean square error and one that is much more lesser than this. It's just note that the lower your any kind of errors that is being measured, the smaller the error, the more efficient your model is. Do you understand that?
Yeah. Yeah.
So initially, you know that in our own particular case, there are bigger values. There are very, very bigger values. So our mean square error might be big, might say there are larger values for house pricing data. It's larger values. So it's expected to be very, very big. Do you understand that? It's very, very large.
Yeah.
Do you get that?
Yeah, I got it.
So let's look at another example. Let's look at another example. So in this particular in our data set, in our data set, if you have something like this, if we need to, okay. So these are our data sets. So maybe if we need to estimate, we want to try to look at the relationship between sales volume and average price. Average price. Do you understand that? Or let's say that
Okay.
let's say that we have our Y like this. Let's say that we have from this house pricing, this average price for all property type. Do you understand that? You want to use the previous value to make the next predictions. Like you want to know that, for example, in this particular month, 2008, January 2008, this particular value, the house price is this 298,596. So with this particular value, we want to use to predict the next value. Do you understand that? You want to use the previous prediction, like a time series prediction. For example, now you know the price of a particular house today in this particular month. You want to use that price to predict the next month price. Is that clear?
Yes.
Do you understand what you intend to do? You want to use the immediate previous price to predict the next one, to predict the current price. Do you understand that? Or immediate or the current price, you want to use to predict the immediate next price. Do you understand that? So if you want to generate our data now, we can then say that average average price for all types. This is our data. So we can just convert this to values. So these are to values to Numpy arrays, something like this. So for us to now extract our x now. So we should know that our x will be from year to year. Do you understand that? Our x will be from year to year. This one will be excluded. I'm going to tell you the reason why. And our y will be from year to year. Our y will be from year to year. It means that our y value will start from the next this one and it's going to stop at the last one. And our x value will start from the first one. It's going to end at the one before the last. Which means that at the first one, the first item will be that this will be x in the first observation, and this one will be x1, this one will be y1. Do you understand that? In the next one, this one will be x1, this one will be x2, this one will be y2. Do you get that?
Okay.
Yeah.
It's very clear. So for us to do that, we can then say that let's say that this is our pricing data is equal to this. Then for us to extract x values, so it will be pricing from 0 to -1. That means that we are not taking the last values. and y is equal to and y will be equal to prices 1 to end. So we are taking the first one. We are starting this one. We are starting from the first one, but we are not getting to the last one. But this one we are starting from the second house pricing, and we are getting to the last. Do you understand that?
Okay.
So with this now, we can then use our linear regression model. We will use our linear regression model, which is this. So we don't need the formula again. We just need to use linear regression model from Sklearn. Reg equal to linear regression dot fit x comma y. So I think we have to reshape it again because x dot shape, the shape is not well in, it's just 156. So it should be 156 comma 1. So let's say the new shape will be, our new shape will be equal to we want it to be in length x comma 1. So our new shape is equal to x equal to np dot reshape, np dot reshape x comma s. So we do the same thing for y. So then we can then make prediction y pred will be equal to reg dot predict x. So then we can then make plots. We can then plot our graph. So but in this case, the x value is what? The x value is not GDP. The x value is previous pricing. Previous price. Do you understand that? The x value is previous price. Why this y value is current price? So it means that we are using the previous price to predict the current price. Do you understand that? So this predicted an actual pricing. So something like this.
So when we say predicting, are you trying to say that if you want to have like a practical explanation, for example, if the current price is like 500, so are you trying to say that based on this result, we'll be saying in 2 years' time, maybe the price can increase to like 1,500 or maybe 1,800?
Yes,
Is that the
exactly.
meaning of
Yeah,
predicting?
exactly.
Okay.
So what linear regression does is that it's trying to estimate the relationship between the previous price and current price using the historical data you've collected. Then with your slope and your intercept, you can predict new pricing. Do you understand that? But
Okay.
in a real life work, we want to do a analysis, we want to make an analysis. It's always good to split your data using the techniques called cross validation process. The cross validation. So in cross validation, we split data into testing and training and testing sets. So what I mean by cross validation, because validation is a process of evaluating your model. So because now we cannot say our model is just like this. This we cannot just split this particular analysis. It looks too simple because our model, we are using the same values that is being used to train the model to predict. Do you understand that? So in most cases, you can maybe you extract from January to December, or you extract from 2008 to 2015. Do you understand that? Then you want to now predict from 2015 to 2020 to use to
Okay.
evaluate your model. Do you understand that? It's just like you train a particular model. You train a model from 2008 to 2015.
Okay.
Then with 2008 to 2015, you've extracted your intercept and your slope. And the intercept and the slope now, you now want to use to evaluate the model from 2016 to 2020. By then, you can then estimate that this is how your model is. This is how your model works. But with this now, we just combine the two data together. We don't perform cross validation. So now we are going to perform cross validation. In cross validation, you need to split your data into training and testing.
Hmm.
So you need to split data into training and testing sets.
Oh, guys, taking us into machine learning.
Yes, we're already into machine learning already, but I'm still going to, by next class, I'm going to introduce you to some techniques in machine learning. So we'll start from afresh again before getting into it deeply.
Okay.
So in cross validation, we have the training sets. You have to split your data into training and testing. There are several techniques for validation, cross validation techniques, training and testing sets. So to split data in Sklearn, so you can just come here. Once that you want to split data in Sklearn, so split Sklearn, split. So this split test. So there's a split test function under model.selection. So we have from Sklearn dot model underscore selection import tests train underscore tests split. So let me look at it very well. Train underscore test underscore split underscore split. So this is this function that is going to be used to split the model. So better still, I can just copy the example that is being used here. So once you have this example, but you have to be very careful if you are splitting in this case, because you can split randomly, then you can specify that you don't want to split randomly. You understand? You understand that? But in this case, you don't have to split randomly because we are taking the previous and the, even though if you even split randomly, it might even get that might not be a problem. So once you split this particular x and y, you can split x and y. You specify your test ratio. The test ratio means that you are splitting it. This one means that you are having a test set of 3%. So I can just reduce it to maybe 25%, 0.25. That I only need a test set of 25%. Why? I have a training set of 75%. Do you understand that? So once you split your code, you have your X train and Y train. So this X train and Y train is now going to be used to train the model. Do you understand that? So if you want to train the model now, we don't need to train the model with all the data sets again. So we only train the model with the training sets. These are the training data and the target training. Then we can then predict with the right page. Then we can then predict with the reg.predict with the testing sets. You understand that? You can predict with the testing sets. So from here, then we can then plot our graph again to see how well our model is being it's able to predict the values. So in this case, we are going to use the testing set. Okay, y x twin, okay, x test. So we need to plot the x test and y test. So then we also need x test and y predict. So this is the data now. This is the representation because we only pick 25%. We only evaluate our model with 25% of the whole data set. That is why it looks like this. So this is the model. This is a visual evaluation of the model.
So, sir, what is the interpretation for this?
So if you look at this very well, this is much. The lines are well fitted now, even though we train. Let's have a break in this session. In the next session, I'm going to explain.
Okay.
I'm not going to add new code. I just want to explain much more better on what we've done.
Okay. Okay.
So I'm going to explain the cost validation process to you very well. So what we intend to do is that we have house pricing data. Do you understand that? We have house pricing data for several months, which extend to several years. Is a monthly. You understand? Just like we have, let's say we have fees for 2008, 2008 to 2020. Do you understand that? So it's in monthly, so it's in every month. So what we tend to do is that we want to create a model that can predict the next house pricing, given that it knows the current month. For example, if we are in, for example, we are in July now. We are in July. We want to predict for August. We want to predict for August. If I thought the house pricing is maybe $50 here, is 50 here. We have an house price of 50 here. Then we want to, in this particular month, in July, we want to predict for the next month. Do you understand that? That is what we intend to do. We want to predict the next month, August, after we already know that for this month is 50. We want to predict for the next month. Then what we need to do is that we've collected our data sets, our historical data. We've collected historical data from maybe 2008 to 2010. So this historical data now, they are represented in form of months and they are represented in monthlies. So we now create X and Y values by taking previous month and current month. For example, we are for a particular data observation. If you take X value as January, Y value will be February price. Do you get that? If X value is January house pricing, Y value will be February house pricing. And the next observation will be if X value is February house pricing, Y value will be March house pricing, so that we can merge them together and create a mapping functions using linear regression formulas in which you can get the slope and the intercept. Do you get that? In which you can get the slope and the intercept, and with the slope and the intercept, we already have a linear regression model that can be used to predict subsequent house pricing. So do you get that?
Okay.
So if you are analyzing your data sets, for example, you are giving data set for like from January to, you are just giving data set for up to maybe 2000 to 2020. You understand that you can't use all the data sets to create your model and evaluate your model. Do you understand that? It's just like you train a particular robot. You train a particular robot on how to wash, how to identify maybe a you want to identify deaths Do you understand that you want to, okay, let's say you train a robot on how to identify a person face. Do you understand that? Then you train that robot with maybe a new, maybe you just want to identify that maybe a particular person is in a particular vicinity, just to identify persons in vicinity, and the robot is going to work in such a way that once it identifies the person, any a particular human face, it's going to raise an alarm that human is in that particular vicinity. Do you get that? So if you train that robot using maybe my own face, you train the robot using my own face and your face. If you want to evaluate that robot, if you are evaluating the whole robot with my own face, the robot is more likely to identify my face because it's been trained with my face. Do you understand that? But once you bring new face and you evaluate your robot, then you can then know that your robot is actually working fine. So that is the reason why we do split our data set into training and testing. The training set is used to train the model, while the testing set there are new data entered that the model have not seen before. That is going to evaluate the model with it. Do you get that?
Okay, that's the testing data.
That is testing data. It's just like
Okay.
you have a data set like this. Maybe you have 50 observation of data sets, and the 50 observation of data sets it ranges from maybe 2000 to 2010. Do you understand that? Which is monthly. Then you can't use all this data to train your model and evaluate it. So that is why the cross validation process comes in. Cross validation process techniques is a techniques in which we split data sets into training and testing. Why the training set is going to be used to train the model, and the testing set is going to be used to evaluate the model.
Okay.
Do you understand that?
Okay. Yes.
So if we now let's go back to the code. If you look at what we did here, so in this particular data set, this is our data set. We have house pricing data. House pricing data in monthly. This house pricing data, average pricing for monthly prices. So we extract the X values. Now we extracted the X values, starting from the first observation to the one before the last observation. Why the Y values starting from the next observation after the first observation, which is the second observation, to the last observation, in such a way that the first observation can match with the second observation. Do you understand that? So after we get that, we will shape our data in such a way that it can accept the size of the data set. But in this first implementation, we use the old data set, X and Y. Then we predict again using the X that we train the data, we train our model using the old X and Y data, and we also predict using the X and Y X data. So if you have done something like this, maybe you are the answer that your model is performing well, and someone look at a professional look at it that this your model might be performing too well because it is being trained and evaluated using the same data. Why don't you try a new data sets and see how the model is going to work? So that is why we come up with an idea of splitting the data set here. So in this case, we now split the data set into training set and testing set. So we now have four variables. We have the X value, X input of training, Y input for Y training, X test, Y test. So then we specify the testing ratio to be 25% of the data set. That means that we are using 25%, taking 25% of data set for testing, and we are using 75% for training.
But sir, is this like a formula?
You mean this particular line, Aaron?
Yes.
It's a code. It's a code. This is a code to split X and Y. This X and Y is going to be split into training and testing. You know, X and Y are two things. We have X and Y. So in X, we have X train and X test.
Yeah.
Training input and which is the testing input. In Y, we have Y train and Y test. Testing targets for the training and the target for the testing.
Yeah, but because of the equal sign here, because of the equal sign in the middle, that's why I'm asking if it's a formula. For example, if you want to do it maybe subsequent to another one, is it compulsory that we have to put this X train, X test, Y train, Y test?
No, this is just a variable. This is just a
Okay.
this
I understand that.
you understand that X underscore
Yes.
train, meaning that it's just this is not a formula, they are variables. It can be X train like this. They are variables.
Okay.
You understand that they are variables. So once you need that, you know that this is your training values, this is your training data now, and this is your training data. Then now we can then predict with this X test, which is a new data set entirely. So they will predict it here. So by now we can then compute our mean square error, which was being evaluated here. So look at where this mean square error. You can use mean square error to now see how well our model is performing.
But sir, in that graph, I'm seeing the underscore is still retained and the graph is still showing. So my question is, hope it's not operating on previous data.
Yes, for previous data. Thank you for that. It's for previous data. So, but it's the same data. We just change the variables name, just for you to
Okay.
understand that whether it is
Okay.
y underscore y. So this y test. So this is the mean square error. Do you understand that?
Okay.
So do you have any question? Do you have any question?
No, not for now.
Well, this mean squared error, is error for what?
Is that what? Hello?
This mean squared error is error for error on what?
We have you know that we have our predicted values and our actual values. Is an error that what is the difference between your actual values and what you predict? Do you understand that? So that is what we mean by the error. Do you understand that? Mean square error is just a performance measurement method that measures the difference between the just
Actual
like you have the actual and the predicted. Just like you have predicted that maybe your house pricing for next year month, you have an current house pricing of 50 now. You are predicted that your house pricing for next month will be 55. Then it actually comes to be maybe 56. Do you understand that? So the difference there is the error. But in our case, we have several months that we've selected as the white test data.
Yeah.
There are several ones that we selected. So for us to get a single value, a single error, there will be error for each of the values that have been selected. So that's why we use mean square formula to compute all the errors together and find the mean and square them. It's just an error measurement. No, I thought that we also have mean absolute error and root mean square error.
Yes.
So is that okay?
Yes.
Okay, so that is that about that. Do you have any question? Ojina, do you have any question? Justin, do you have any question?
No question.
Well, this linear regression of a thing, since it's still not very clear, I have to watch the video over and over again before I can grab it. You understand? No need of asking questions. Yeah.
Okay.
I have to use this weekend and practice on it.
See, the
and this particular class, I don't know whether it's my phone. Your voice wasn't loud enough. I couldn't get what you're saying.
Really, I'm sorry about that, but I'm not sure. It should be louder. But once I'm going to look at the video, if I can edit the video and make it much more audible for you to get what I'm doing, for you to get the lesson in this class. Is that okay?
I have to linear regression started and start following it. So
Okay, but you have to understand the concept behind the linear regression model. You have to understand what we intend to achieve. That's why I took my time to explain that what we intend to achieve. Do you understand that? So you have to understand that. So
Okay.
I'll see you in the next class. But before then, please, yesterday assignment, make sure you do the yesterday assignment and upload it to your folder. I told you to always upload it to your folder.
Okay. Okay.
Is that okay?
Okay.
Okay.
Thank